So hey there, my name is Prajwal Hukerikar and in this video we are going to learn about what's inside of a microcontroller. So basically, let's discuss what is a microcontroller first. So microcontroller is simply a single chip computer which we design to perform predefined tasks. So what is a predefined task? Let's consider an example of a refrigerator. So what happens in a refrigerator is basically when a certain temperature threshold is reached, the power supply to the compressor is turned off. And again, when a certain temperature threshold is reached, the power supply to the compressor is turned on. So what happens in a refrigerator is that we have a microcontroller along with a temperature sensor. So the temperature sensor continuously monitors the temperature levels inside of the refrigerator and feed that data to the microcontroller. And microcontroller again continuously monitors all that data and it analyzes it. And when it observes a certain temperature range, it turns on or off the power supply to the compressor. So this can be a general application of the microcontroller as well. And again, it has some different characteristics such as a microcontroller has low clock frequency as compared to the microprocessor, which is generally in the range of at max in the few hundred megahertz. Okay, so again, it has very less memory as compared to the microprocessor, and the major key factor is over here is that it is very power efficient and way much more cheaper as compared to the microprocessor, and that is the very main reason why we use them in an embedded system. So what is an embedded system? So basic definition of a embedded system can be embedded system is generally a collection of hardware and software which we design to perform a particular predefined task. Okay, so for an example, to understand what is inside of a microcontroller, we are going to consider Atmega 328P, which is Atmel's very famous microprocessor, and again it is used on the Arduino's Uno board. So let's just understand what is inside of this microcontroller and what is the functionality of each pin. Okay, so this is basically the pinout of this Atmega 328P microcontroller, and over here we have the respective Arduino pins. So this is, I guess, very good example to begin with. And okay, so what we have here is basically we have three ports, that is port C, port D, and over here we can see the port B. So for port C and port D, port B and port D, we have 8 pins, and for port C, we have 7 pins. So what is a port? Let's just get to know that first. So a port is basically a collection of connection to the peripherals. Again, I'll repeat that. A port is basically a collection of connections to the peripherals. Okay, so uh, again, let me go to the datasheet of this microcontroller. So for those of you who don't know what is a datasheet is, so a datasheet is basically a user manual which generally the manufacturer designs to give the information regarding their parts, and it is very important if you are an electronic student. So you must understand the datasheet of particular ICs or components that you are going to use or that are in your syllabus. Okay, so I'll just scroll down from here because we don't need. So over here you can see that there is different packaging, that is TQPFP packaging. Like I said, it has 32 pins, and again, this is a PD packaging that we are seeing on the screen before. So it has 28 pins. Okay, so I'll just scroll down over here. So here you can see the register summary. So register is basically memory storing element, which is very simple memory storing element. So these are the addresses, and these addresses are basically used to deal with the ports. But we are not currently studying embedded systems, so I will skip that part and I'll just jump over here. Okay, so now we have an idea about ports and register. So as if you're using the Arduino board, you don't have to consider it with the ports and registers because Arduino does all the job for you. Like Arduino IDE converts everything in the machine language that you type in a simple C language. Okay, so okay, over here we have the block diagram of Atmega 328P. So this is going to be a very important part. I suggest you to write it down, whatever the points I'm saying. So this is the main CPU, and it also has embedded ALU, that is arithmetic and logic unit inside of it. So this is the heart of any microcontroller. Okay. So after that we have the flash memory. So a flash memory for this particular IC is of 32 kilobyte, and again it is divided into two parts. So in that 32 kilobyte, 0.5 kilobyte memory is consumed by the bootloader, and the remaining memory is basically called as program memory. Means you can store whatever the program that you have written, you can store it in this particular memory. So this is a read-only memory, that is ROM memory. So again, like I mentioned before, bootloader. So what is a bootloader? So bootloader is generally a set of instructions for a microcontroller. So basically, when we start the microcontroller, so there are some instructions for that microcontroller to begin with. So that is a very important program, and we have to flash the bootloader first before operating or uploading any program onto the microcontroller. Okay, but Arduino does all that job for you as well. So the bootloader for the Atmega 328P is pre-flashed on an Arduino board, so you don't have to worry about uploading the bootloader program to this IC or microcontroller. Okay, so now after flash we have EEPROM, that is electrically erasable programmable read-only memory. So for this particular IC we have 1 kilobyte of EEPROM, and which is non-volatile in nature. So this is a fixed memory. Again, we use this particular memory as a separate memory element, and we generally use it to read the single bytes. So main point for both flash memory and this programmable, electrically erasable programmable memory. So for both of them, the life cycle is limited. Like there is a particular cycles of reading and writing for these both memories. For this flash memory, we can only use it for 10,000 reading or writing cycling. Okay, so this is not a permanent memory, and after 10,000 read or write cycles, it will lose its reliability. And for this particular memory, that is EEPROM, it is 100,000, that is 1 lakh read and write cycle. But we generally don't deal with this memory. We are only going to consider with the concerned with this type of memory. Okay, after that, over here we have SRAM, that is static random access memory. So a program memory and program data, that is entirely different things. So for the flash memory, we are going to upload the program which we have written over here, and in this SRAM we are going to so whatever the data that is generated while the execution of the program is going to be stored over here. So SRAM for this particular IC is of 2 kilobyte, and which is volatile in nature because it is again random access memory. Okay, so again you can see over here that this is a data bus, and this is input output data bus. And main thing over here is that the flash memory, or let's say ROM and RAM, are not a single unit. They are connected differently. Like RAM is connected to this bus, and the memory, that is read-only memory, is connected to this bus. Okay, so it is the indication of a Howard architecture. I'm not going to be discussing that right now. I'll make a separate video for the architectures and types of the microcontroller. Okay, after that, we are going to be considered about this clock generation. So for this particular IC, it can support low power crystal oscillator, full swing crystal oscillator, as well as low power crystal oscillator, that is low frequency crystal oscillator, as an external oscillator, but it has internally two oscillators which can generate the frequency of 2 to 8 megahertz, generally 8 megahertz. But again, for the CPU, the memory get divided by 8. So when 8 megahertz of the clock frequency is generated over here, the CPU is generally operating on 1 megahertz. So this is the thing over here, and again we can connect the external oscillators to it to perform the general clock generation. Again, after that, we are going to be considered about this watchdog, then TC1, TC2, and over here we have TC0. So these are basically the timers, and These three are general timers, and this is a real-time timer. So TC1 is basically a 16-bit timer, and TC2 and TC0 is basically 8-bit timer. So this watchdog timer has an internal oscillator, and it is programmable. So whenever there is some software malfunction, so this generally does the recovery by resetting the entire microcontroller. So this watchdog timer is very important for the total functioning of this microcontroller. After that, we are going to be considered over this SPI, again this TWI, and USART, that is USART. So these are the three communication protocols supported by this microcontroller. So SPI stands for Serial Peripheral Interface, and it is very common and very fast protocol to be considered with. And again, after that, we have USART, which is basically Universal Synchronous and Asynchronous Serial Receiver and Transmission Protocol. Okay, so USART is a very flexible protocol, and we generally use it to communicate with the development board, and we generally use the SPI protocol to deal with the input output peripherals. And after that, we have TWI, that is two-wire interface. So two-wire interface can support 120 different devices, and as well as the other AVI microcontrollers, and it is compatible with the Philips IC2 protocol. So that is I2C protocol. So that is really important function of this part. And after that, we are going to be considered after this GPIO pins, that is input pins. So like I said before, that there are three ports, that is port B, port C, and port D. So these are those ports, and the operation of these ports is carried out like there are 23 input output general pins, and out of them 14 are basically the digital pins, and 6 are analog pins, and after that we have some other pins as well with that. So this generally okay. So the power supervision and BOD and reset. So this is very important block of this entire microcontroller, because the power, BOD generally monitors the entire power supply level for this board, and again when a certain the voltage level below a certain threshold is fed to this microcontroller, then it generally turns off or like resets the entire microcontroller to provide uh, avoid any malfunctions. So this basically, yeah. So again, we have this ADC and AC. So ADC is generally analog to digital converter, and AC is analog comparator. So analog comparator does what analog comparator does is basically it compares the analog voltages that are fed to this particular um, block, and again it gives the output to this data input output data bus, and analog to digital converter is basically an analog to digital converter means it converts the analog signal to the digital signal, and again it generates 10-bit output for this particular microcontroller. It generates 10-bit output and it feeds it to the data bus, which is again provided to the CPU for further processing. So this basically generally sums up all the blocks of this Atmega 328P microcontroller. And with this, uh, why we discussed all these pinouts and microcontroller board is basically, as you can see here, I have the schematic of Arduino Uno board. It is the official schematic of the Arduino Uno board, and over here you can see this is Atmega 8U2 microcontroller, and again here we have 328P microcontroller. So this is the different packaging, and it has 32 pins, but what we seen just by now what was of 28 pins, but that doesn't really matter right now. Okay, so these are different components of the board, and here we have the reset button, and this is generally the power supply, and this is the comparator, so voltage comparator. So in case I connect the both power to the USB cable, and if I'm powering the USB Arduino Uno board through the USB cable as well as from the barrel jack, so in that case this voltage comparator compares both the voltage levels and only passes a single voltage whichever is suitable for the functioning of the board, and it blocks the other voltage level. Okay, And over here we have the power junction, that is basically reset, and again this is a pin for 3.3 volt. This is for VN, and this is for general ground, and again this is for 5.5 volt. Over here we have the crystal oscillator, which is external crystal oscillator for this particular 328p, and again we have crystal oscillator for this 8U2. But this is an older revision of this board, so there is an 8U2 board, 8U2 microcontroller, but in the third revision we are using 16U2 chip. Okay, and again here you can see as this is the TX LED and RX LED, so these are just indications. So, yeah, so that's what I wanted to tell you, that once you are familiar with the microcontroller, that is the actual microcontroller, you can design your own development board, or you can just erase out all the unnecessary part and create a different Arduino compatible board according to your purpose and your need. So this was it for this video, and again, I'm gonna sum this up with a note that I haven't discussed about the how architectures and types of the microcontroller, so I'll continue that in the different video. So okay, thank you so much for watching.